Get teach her now where chemistry is made easy. Please like, comment, share, and subscribe. Bye.
Hello, good day viewers. Today we're having double decomposition reaction. Double decomposition reaction. A double decomposition reaction is one in which the reactants decompose to form new substances by exchange of radical. I repeat, a double decomposition reaction is one in which the reactant decompose to produce new substances by exchange of radicals. Now, in double decomposition reaction, the reactant are said to be what? Soluble in water. Yes, the reactants, they are soluble in water. That means they dissolve in water completely. The two reactants dissolve in water completely. So once you now react them together, they are going to form one soluble as the product and one insoluble as the product. So that means they'll be having two products. One is soluble, one is insoluble. Double decomposition reaction is always used to produce what? Insoluble what? Salt. Insoluble salt, that means salt that cannot dissolve in what? In water. Now, let's have what we have on board. We have A plus B. We have to give you what? C plus D. Now, this one is going to be soluble, this one is going to be soluble. One of these two is going to be insoluble, and if it is insoluble, I will write S. Then this one that will be soluble, I will write AQ. This is just a little description of what I want to do today. So this is now. Let me now go to the main work. So, like, don't forget that double decomposition reaction is used in the preparation of insoluble salts. Now, let's have silver nitrate. We have AgNO3. I write my aqueous because it is soluble in water, just like this. Then, plus what? Plus, I will have my sodium chloride, NaCl, aqueous as well soluble. Then, reacts to give you, this is a double decomposition reaction. This will react to give you what? I will write this. Okay, before I even complete it, the definition says that by exchange of radicals. Yes, let me take you guys to that place. By exchange of radicals. Now, what are the radicals here? And what are the radicals here? For this first, we have Ag plus NO3 minus. These are the two radicals we have on this one. So we now have for this side Na plus Cl minus. Do you understand now? So they are going to exchange their radicals to form the one that will be insoluble and the one that will be soluble. Now let us have the exchange now. So this is positive, silver. This is silver. Silver will now go to what? To negative. Yes, because we said that unlike charges they attract, while like charges they what? They repel. So unlike, they are unlike, plus minus, so they will attract each other. Then, while for this one also, this is NO3 minus, it will now migrate to this one that is what? Na what? Plus. So let's join them together now. We are picking the one that are metals first. This is a metal, silver is a metal, sodium is a metal. So we are picking this one first before this one. Then we are picking this one first before what? This one. Now let's have it. Now we now have AgCl. We have AgCl solid. That is the one that is going to be. Then the last one is NaNO3. That will be the other one. We have NaNO3 aqueous. Do you understand? Let's check if the equation is balanced. Silver is how many here? 1, 1. Nitrogen is 1 here. Nitrogen is 1 here. There's N here, NO3. Oxygen is how many? 3. Oxygen is what? 3. Sodium is 1. Sodium is 1. Na1. Chlorine is 1. Chlorine is 1. The equation is what? Is balanced. So this one is the insoluble. This is the insoluble. This one is soluble. Alright, let's have the practical without wasting time. So this is my silver nitrate. This is my silver nitrate, AgNO3. Then this is my sodium chloride. This is my sodium chloride. That is this one, NaCl. So this one is my silver nitrate. So let me get my, this is my boiling tube. Okay. Then this is my salt. Okay. Then we have to dissolve it. This is my distilled water. So we stir. This is sodium chloride, is soluble in water, and silver nitrate is also soluble in water, because in the double decomposition reaction, the reactants are soluble. The reactants are soluble. You can see soluble, which is this one. You can see it's like water. See, it's soluble. Then the other one, which is this, also soluble. Then see this. This is the sodium chloride, which is this one. This is the sodium chloride. Let me put here. You see what I put here? Let me add a little. See it. So I keep this one. Then I take another test tube. This is the silver nitrate. I put some here also. You can see it. So now, once I mix these two solutions together, you are going to see white precipitate. You are going to see white precipitate. The white precipitate is the silver chloride. That is AgCl, silver chloride. While the one that is soluble inside is going to be what? NaNO2. So let's mix them together, because we are preparing an insoluble salt. And what salt are we preparing? AgCl. So let's see it. You see it now. You see white precipitate. You can see it. White precipitate. You can see it. So now, how do we get our silver chloride and sodium triisonitrate 5 NaNO3? This one, how do we get? So we have to get that through a filtration process. So this is my, let me keep this here. So you already know how to fold filter paper. You fold filter paper first half. So let me be fast. Then you turn it again. So you have a cone shape. So you open one on the side. So let me get it from there. Is it? Then we place it here. Place it here. Then we get, this is an empty test tube. Place it here. Then this is it. Shake it very well. You can even see the bottom. So okay. See, there are some solid already. So let's keep it so that the separation can take place. Let's keep it here. So let's wait for it to be. Okay guys, I believe our filtration process is complete. So this is our filtration process. So the particles or the liquid that passed through the filter paper, is called filtrate. So this is our filtrate. The liquid that passed through the filter paper is called filtrate. This is the filtrate. While the particles left on the filter paper after filtration is called the residue. So here now, this water, this clear liquid you are seeing here, it is the what? NaNO3 because it is soluble. So we have separated this one from this one. You know, when we mix the two together, it gave us a white precipitate, right? A white precipitate. Now we have separated that precipitate. We are able to produce our insoluble salts. This one is insoluble, that is silver chloride, AgCl. It is insoluble. It can't even dissolve in water. It doesn't dissolve in water. It does not. So this is insoluble. This one is what? Soluble. So this is the filtrate. This is the residue. So I can keep this on here. So we just prepared an insoluble salt in the chemistry laboratory. So we just prepared an insoluble salt in the chemistry laboratory. So this is our insoluble salt. You can see it. Can you see it? You can see it. So this is our insoluble salt. It's small, right? Yes. If you want to make it big, you have to add more of your sodium chloride and you add more of your silver nitrates. Yes. You add more of this, then you will not use filter. I don't know if you will get filter paper that is bigger. So if you want to produce higher mass of this. Do you understand? So this is our result. This is our insoluble salt that we prepared through the process of double decomposition reaction. Thank you for watching my video. Please subscribe to my channel, like and comment and share to your friends. Thank you. God bless.